Hello, welcome to my channel. Today we'll be talking about standard forms. So what is standard form? Standard form, also known as scientific notation, is a way to express very large or very small numbers. For example, distance from the Earth to the Sun is 149.56 million kilometers. That could be a lot to write. Now in standard form, what that will be represented as is 1.49 times 10 to the power of 8 kilometers, or 1.49 times 10 to the power of 11 meters. For another example, the mass of a proton is this. That could be quite a nightmare to read, but in standard form we can convert it to 1.67 times 10 to the power of minus 27 kilograms. With standard form we can see whatever power is, that will be our indication whether the number is going to be very large or very small. So from the two examples that we saw, to the power 11 will suggest that it's going to be a very large number because it's a positive, and a negative 27 will suggest it's going to be a very small number. So what does standard form look like? Standard form has a format of a multiplied by 10 to the power of b, where a is any value between 1 and less than 10. B is often a good indicator to tell us whether the number is going to be very large or very small. So the two typical questions that you will have on standard form would be converting from ordinary numbers to standard form and from standard form to ordinary numbers. So this is what we're going to cover in this video. How would we convert ordinary numbers to standard form? Some of you may know that you might have heard of the method of counting the zeros. Here we're not going to count the zeros purely because if you're given a decimal like 2.48, counting zeros will no longer work, and you'll see later why. Instead, we're actually going to focus on the decimal point. Some decimal point will be slightly hidden. For example, 5, 24, 150, they all have decimal points, but they are after the last digit. So for example, 150, you have 150 point, and that's where your decimal point will be. So the idea of converting ordinary numbers to standard form is moving the decimal point. We want to move the decimal point until the number is reached within the specific bracket for a, and where a will be the value between 1 and less than 10. So let's go to an example. So for this example, we have 478 million, and we need to write that in standard form. So the first point is to find out where is the decimal point going to be, and the decimal point will be at the very last, so after the last zero. Then we will need to move the decimal point to the left. Because it's quite a large number, we're going to move it to the left so it gets closer to the number between 1 and less than 10. And then we will need to count. So from the decimal point where it is now, we would count each time we move the decimal point 1 to the left. We count 1, 2, 3, 4, 5, 6, 7, and 8. Our decimal point reaches the number between 4 and 7, which will make 4.78. That means the answer for this particular example will be 4.78 times 10 to the power of 8. Now let's do a small number. This time we have 0.0000478. Again, we have a decimal point, and this time we will need to move it to the right. We move it to the right because the number will become larger, but we need to also need to compensate it with the powers, which we'll look into later. When we move it to the right, we're going to do the same thing. We're going to count 1, 2, 3, 4, and 5. This brings us to the value of 4.78 times 10 to the power of minus 5. The minus 5 tells us that the original number was a very, very small number, so that the value of the number is very small. So when we're talking about compensating with the powers, the idea is that because we are making the numbers larger, from 0.0000478 to 4.78, we need to compensate it by the power. So times 10 to the power of 0 initially will now be times 10 to the power of minus 5, because times 10 to the power of 0 will equal to 1, and then times 10 to the power minus 5 will be 1 over 10 to the power of 5. So we're adjusting the way it's written, but the actual value still stays the same. Another way to think about it, if you're going to move the decimal to the right, the power will be moving in a negative direction, going smaller. If you're moving the decimal point to the left, the power will be moving into a positive direction, so the number is going to be larger. So here are some questions for you to try. Pause the video, give it a go. When you're ready, then we're going to go through the answers. Right, so on the screen now you should be able to see the answers. So question 5 is a little tricky because 1.5 is already between 1 and less than 10. We actually don't need to change the number itself, but because the question states that we would need to write it in the form of times 10 to the power of something, we will just simply put times 10 to the power of 0, because times 10 to the power of 0 equals to 1. Therefore, we're not multiplying, we're not adjusting the actual value itself. We are just writing it slightly differently. So times 10 to the power of 0 is the same as multiplying anything by 1. So the actual answer 1.5 times 10 to the power of 0 haven't changed the actual value. It still stays as 1.5. So now we know how to convert from ordinary numbers to standard form. We're going to look the reverse of it. Essentially, it's the same thing, but slightly backwards. And we're going to go straight into an example. So example number 1, we have 3.4 times 10 to the power 6. The same thing, we're going to look at the decimal point, which is between the 3 and the 4. Because we know it's times 10 to the power 6, we're going to move it to the right. So we're going to move the decimal point 6 times to the right. And each time we have, after the digits, we're going to fill it out with zeros. So if we do that, we have 3.4 and we're going to times it 10 to the power 6. So we're going to do the count. So 1, 2, 3, 4, 5, 6. And that will give us the answer of 3,400,000. And now another example from the opposite spectrum. We have a very small number of 3.4 times 10 to the power minus 6. Now, because we have a negative 6 as a power, we are going to move the decimal point to the left this time because the number is getting smaller. So we're going to do exactly the same thing. From 3.4, we're going to move the decimal point 6 times to the left. So we've got 1, 2, 3, 4, 5, and 6. And therefore, with that particular question, we're going to have 0.00000034. I hope that makes sense. Now, here are some questions for you to try. Pause the video, give it a go. Once you finish, press play for the answers. And here are the answers. So for question 1 to 4, it's quite straightforward. For question 5, we have 3.4 times 10 to the power 0, which is essentially the same as 3.4 times 1. Therefore, the answer will stay as 3.4. For question 6, we have 3.4 times 10 to the power of 1. Now, 10 to the power 1 is the same as 10 itself, so we have 3.4 multiplied by 10, which will give us 34. I hope you found this video useful. If you enjoyed it, please like and subscribe for more maths videos. Thank you.